Welcome to the video. Here in this video we are discussing module 4 complex integrations Taylor's series expansion. We already studied Taylor series in the previous semester, which is in the calculus. For a real valued functions we have Taylor series expansion. Here we are dealing with the Taylor series expansion of complex functions. Moving to the slides. Taylor series. Let f of z be an analytic function within a circle with the center z0 and radius r. Then for all z inside the circle we have f of z is equal to the expansion as f of z0 plus z minus z0 divided by 1 factorial into f dash of z0 plus z minus z0 the whole square divided by 2 factorial into f double dash of z0 plus etc. plus z minus z0 whole power n divided by n factorial into f nth derivative at the point z0 plus etc. So for any analytic function within a circle with center z0 and radius have a series expansion as like this. So this is the Taylor series expansion of a complex function which is analytic. If the point z0 is equal to 0, then our Taylor's series reduces to the form f of z equal to f of 0 plus z divided by 1 factorial into f dash of 0 plus z square by 2 factorial into f double dash of 0 plus etc. plus z raised to n divided by n factorial into fn of 0 plus etc. Here the point z0 is equal to 0. This series is known as Maclaurin's series. About a particular point z equal to z0, the expansion is Taylor series. For the point z0 equal to 0, the series is called the Maclaurin series. Next, some basic expansions. These are some familiar expansions, that is e raised to z. E raised to z is an analytic function, everywhere analytic function. So the standard expansion of e raised to z is equal to 1 plus z by 1 factorial plus z square by 2 factorial plus etc. like in calculus. This expansion is valid for mod z less than infinity. Similarly, sin z, sin x expansion in calculus. Similar to that, we have sin z is equal to z minus z cube by 3 factorial plus z raised to 5 by 5 factorial minus etc. Okay, since sin z is a odd function, the powers of z will be odd and alternative plus or minus. Next, cos z. Cos z is an even function, so the powers will be of even powers, and the expansion is cos z equal to 1 minus z square by 2 factorial plus z raised to 4 by 4 factorial minus etc. All these expansions are valid for mod z less than infinity. Next, some basic expansions like this: 1 minus z whole power minus 1, similar to the binomial expansion. So this is 1 by 1 minus z. Okay, the expansion is 1 plus z square plus z cube plus etc. This is valid for mod z less than 1. These are the important results which we want in the Taylor series expansion. Next one, 1 plus z whole raised to minus 1, that is equal to 1 minus z plus z square minus z cube plus etc. Next, 1 plus z whole power minus 2, that is 1 minus 2z plus 3z square minus 4z cube plus etc. like 1 minus z whole power minus 2, 1 plus 2z plus 3z square plus 4z cube plus etc. All these expansions are valid for mod z less than 1. These are some important results. Next, we are moving to problems. find the Maclaurin's series expansion of the function f of z equal to e raised to z. Here the function is e raised to z. Here we want to find the Maclaurin series. What is Maclaurin series? About z not equal to 0. So the series expansion will be f of z equal to f of 0 plus z by 1 factorial f dash of 0 plus z square by 2 factorial f double dash of 0 plus etc. plus z raised to n divided by n factorial into f nth derivative at the point 0 plus etc. Here we want to find the functions, some derivatives, and all the derivatives at the point z equal to 0. Okay, let's start with the answer. Here f of z equal to e raised to z. Then what will be f of 0? F of 0 is e raised to 0, that is equal to 1. Then next find the first derivative, that is f dash of z. F dash of z equal to e raised to z. At the point 0, f dash of 0 is equal to 1. Next f double dash of 0 equal to e raised to z. Then f double dash of 0 equal to 1. Up to nth derivative, the derivative becomes e raised to z, and at the point 0, the derivative's value will be 1. Therefore, f of z is equal to, substitute the values in the series expansion. So, instead of f of 0, 1 plus z by 1 factorial into 1 plus z square by 2 factorial into 1 plus etc. Here f of z equal to e raised to z, that is e raised to z equal to 1 plus z by 1 factorial plus z square by 2 factorial plus etc. So this is the Maclaurin series expansion of e raised to z. Next problem. Expand cos z in Taylor series about the point z equal to pi by 4. Here we want to expand cos z about the point z equal to pi by 4. So here z not equal to pi by 4. Taylor series expansion is f of z equal to f of z naught plus z minus z naught by 1 factorial f dash of z naught plus z minus z naught the whole square by 2 factorial into f double dash of z naught plus etc. Here f of z equal to cos z. Then f of z naught. Here z naught is equal to pi by 4. So f of pi by 4 equal to cos pi by 4. That is equal to 1 by root 2. Then next find some derivatives. First derivative is minus sin z. At the point pi by 4, its value is minus 1 by root 2. Next derivative f double dash of z, which is equal to minus cos z. Then f double dash of pi by 4 is equal to minus 1 by root 2. Then the Taylor series expansion. Substitute the values here. So f of z equal to f of z naught. Z naught is pi by 4 plus z minus z naught, that is z minus pi by 4 by 1 factorial into f dash of pi by 4. In the place of z naught, substitute pi by 4. Then in next steps, substitute the values, that is cos z equal to, what is f of z naught? That is f of pi by 4. We got that 1 by root 2. So 1 by root 2 plus z minus pi by 4 by 1 factorial into f dash of pi by 4 is minus 1 by root 2. So minus 1 by root 2 plus z minus pi by 4 the whole square divided by 2 factorial into minus 1 by root 2 plus etc. Here 1 by root 2 is a common term. So 1 by root 2 into 1 minus z minus pi by 4 by 1 factorial minus z minus pi by 4 the whole square divided by 2 factorial plus etc. So this is the Taylor series expansion of cos z at the point z equal to pi by 4. Next problem. Expand f of z equal to 1 by z plus 1 as a Taylor series about z equal to 3 and z equal to minus 2. So about z equal to 3 means we want the series expansion in terms of z minus 3 and its powers, like z minus z naught, then z minus z naught whole square by 2 factorial, like that. We need the series expansion in the factors z minus 3. But here the function is 1 by z plus 1. No factor of z minus 3. So here we want to adjust this function in like this. About z equal to 3. So all the factors of the form z minus 3 and its powers. Here f of z equal to 1 by z plus 1. in the denominator along with the z, just add 3 and subtract 3. So the same effect. So 1 by z plus 1 is equal to 1 by z plus 1 plus 3 minus 3. Then club the factor that we need. Here about z equal to 3 means z minus 3 factors and it. So here 1 by z minus 3 as a single factor, then plus 1 plus 3 is 4. So 1 divided by z minus 3 plus 4. Next, in the previous slides, we discussed some basic expansions, which is of the form 1 plus z whole raised to minus 1, 1 minus z whole raised to minus 1. All the expansions starts with 1, 1 plus z, 1 minus z, like that. So here, we want to take 4 outside. So 1 by 4 into 1 plus z minus 3 divided by 4. Okay, because that expansions are valid only for mod z less than 1. So here in this case it is modulus of z minus 3 divided by 4, which is less than 1. Next, next 1 by 4 into 1 by 1 plus z minus 3 by 4. It can be written as 1 plus z minus 3 by 4 whole power minus 1. We have the expansion like this, 1 plus z whole power minus 1. Substitute for 1 plus z minus 3 by 4 power minus 1. That is 1 by 4 into 1 minus z minus 3 by 4 plus z minus 3 by 4 the whole square minus etc. So this is the Taylor series expansion of the given function about z equal to 3. Here all the factors are in the form z minus 3, z minus 3 power 2 etc. Similarly about z equal to minus 2. So the factors will be of the form z plus 2 and its powers. So here f of z equal to 1 by z plus 1 is replaced as 1 by z plus 1 plus 2 minus 2. Then take the factor z plus 2, then 1 by z plus 2 minus 1. Then taking one term outside. What's the term? 1 by minus 1. Taking minus 1 outside, we got 1 plus z plus 2. So this is of the form minus of 1 minus z plus 2 whole power minus 1. That is 1 minus z whole power minus 1. The expansion is minus of 1 plus z plus 2 plus z plus 2 the whole square plus etc. So this is the Taylor series expansion of the function about z equal to minus 2. Next problem. Obtain the Taylor series expansion of 1 by z square minus 4z plus 3 about the point z equal to 4. About the point z equal to 4 means we need the factors in terms of z minus 4. So next, the answer. Here the function is replaced as like this, 1 by the factors as z minus 1 and z minus 3. Then here there are two linear factors in the denominator. So convert it in the partial form. That is a by z minus 1 plus b divided by z minus 3. On simplification, we get a equal to minus 1 by 2 and b equal to 1 by 2. Substitute it. So minus 1 by 2 divided by z minus 1 plus 1 by 2 divided by z minus 3. Consider the first one, minus 1 by 2 divided by z minus 1. Okay, on the first fraction, we need the Taylor series about z equal to 4. So z minus 4 is the factor. So divide the denominator, add 4 and subtract 4. So minus 1 by 2 divided by z minus 1 plus 4 minus 4 plus 1 by 2 divided by z minus 3 plus 4 minus 4. Club z minus 4, that is minus 1 by 2 divided by z minus 4 plus 3 plus 1 by 2 divided by z minus 4 plus 1. Next, minus 1 by 2 into, here in the denominator, taking 3 outside, then it will be of the form 1 plus z minus 4 by 3 plus 1 by 2 divided by 1 plus z minus 4. Then this is equal to minus 1 by 6 into 1 plus z minus 4 by 3 whole power minus 1 plus 1 by 2 into 1 plus z minus 4 whole power minus 1. Give the series expansion. So this is the answer. Next one, f of z equal to sin z divided by z minus pi. As a Taylor series, that is equal to pi. So the factor will be of the form z minus pi. Here in the denominator we have the factor z minus pi, but in the numerator it is sin z. So first of all we want to rearrange the function as sin z as sin of z minus pi plus pi. Then only we have the factor in terms of z minus pi divided by z minus pi. Then what is sin of pi plus theta? That is equal to minus sin theta. So the result will be minus sin z minus pi divided by z minus pi. Here apply the expansion of sin z, that is minus 1 divided by z minus pi into z minus pi by 1 factorial minus z minus pi the whole cube by 3 factorial plus etc. So this is the answer.